All right, we're going to solve systems using matrices. So a matrix is a rectangular array of numbers. So it's ordering numbers in rows and columns. So a matrix element is each number in the matrix. So one of these values here is called an element. So this is a matrix here, matrix A. This is a 2 by 3. So when I'm looking at my elements here, I actually have my little a here, 1, 2. So the first number tells me the row. The second number tells me the column. So this is row 1, column 2. So that would be equal to 4. So what element is in the 2, 3 position in A? So the 2 says down 2. So the second row, 1, row 2, over 3. 1, 2, 3. I have an 8. Okay? So that's just kind of a little bit of information on matrix, how to arrange them, what they look like, elements. So I can take this, and I can take this system of equations and make it into a matrix. And what I'm going to do is I'm just going to list my coefficients. So 2, 1, 9. I put a bar here, a vertical bar to where the equal sign is. So 1, -6, -1. So this is a representation of the systems of equations in matrix form. So one of the things that we have to understand is when we're in a matrix, when we're doing the solving using matrices, I can switch any two rows. So if I want, I can go ahead and switch these. So instead of having 2, -1, 3 on top, 3, 2, 5 on the bottom, I can switch it and have 3, 2, 5 on top, 2, -1, 3 on the bottom. I can multiply a row by a constant. So I can take the second row here and multiply it by a 2. It's still going to be equivalent. So I end up multiplying the whole second row by 2. So 3, 2, 5, 4, -2, 6. And I can add a row to another row. So I'm going to add the bottom row to the top row. Okay? So I'm going to take 3 plus 4, 2 plus -2, 5 plus 6, and the bottom row just stays the same. Okay? So then I get 7, 0, 11, 4, -2, 6. So we're going to use this idea of multiplying by a constant and adding to solve the systems of equations. Now, a lot of you would probably look here and go, oh, well, I can multiply the top by -2 and then simplify that and get my y, be able to take that and plug it back in and get my x. Totally true. The nice thing about matrix, solving with a matrix, is that when we start getting into really complicated equations, let's say we have 10 or 15 variables and we got 15 equations, there's a little bit of kind of niceness about using a matrix to solve that, because we can kind of do a lot of things at once. So the first thing I'm going to do is I'm going to rewrite this in matrix form. So I take my coefficients 1, 4, -1, 2, 5, 4. Okay, so now I already have a 1 in my first spot here. So this is basically what my x is going to be. So it's going to say x. Now, I want to get rid of this second one. So up here, remember we said, oh, you could have multiplied by -2. Absolutely, you can. So what I'm going to do is I'm going to take and multiply my first row by -2 and then add it to my second row. And that becomes my new second row. So I go -2 times 1 is -2 plus 2 is 0. -2 times 4 is -8 plus 5 is -3. -2 times -1 is 2 plus 4 is 6. I now take this 0, -3, it becomes my second row. Okay? Now, I'm going to go ahead and multiply that row by -1/3, or I'm essentially dividing everything by -3, okay, because I want this to be a 1, okay? So when I multiply by -1/3, I get 0, 1, -2, okay? So 0, 1, -2. I now know what y is equal to, okay? Y is equal to -2. Now, I need to get rid of this 4, because up here I have 1x plus 4x equals -1. I want to know what x equals. So what I'm going to do is I'm going to multiply the second row by -4 and add it to the first row. So I have -4 times 0 is 0, plus 1 is 1. -4 times 1 plus 4 is 0. -1. Then I have negative 4 times negative 2 is positive 8. Negative 1 plus 8 is 7. So now I'm going to rewrite that as my first row. So I have 1, 0, 7, 0, 1, negative 2. That tells me my solution to this is x equals 7, y equals negative 2. As a coordinate, it's 7, negative 2. So you want to be able to, you're doing the same thing you were doing in your process of elimination. But what we're doing is the nice thing here is we're eliminating everything but one variable. So if we had 3 equations, I could get 1, 0, 0, 0, 1, 0, and 0, 0, 1. If I had 10 equations, I would have that where each column only had a 1 in it, and each row only had one 1 in it. So that's an introduction to solving systems using matrices.